Assalamualaikum. The topic for today's optics of ametropia. At the end of this presentation, the audience will be able to define ametropia, describe myopia, hypermetropia, astigmatism, explain and isometropia, interpret pinhole test and synoptic slit, and discuss optical correction of ametropia. What is ametropia? It is a refractive state of an eye where parallel rays of light coming from infinity are focused at the sensitive layer of the retina when accommodation is at rest. Ametropia is the opposite, in which the parallel rays of light do not focus on the sensitive layer of the retina while accommodation is at rest. Types of ametropia are mainly three: myopia, in which distant objects are more blurred as compared to near objects; hypermetropia, in which close objects are more blurred than distance objects; and astigmatism, in which objects are blurred both for near and for distance. Myopia is also called nearsightedness or short-sightedness. In the myopic eye, the second principal focus lies in front of the retina, as can be seen in the diagram. Types of myopia are broadly two: axial myopia, in which the length of the eyeball is abnormally long, and example is high myopia that can also lead to posterior staphyloma. Refractive or index myopia, in which the normal length is present but diopteric power of the eyeball is increased. For example, in keratoconus, in which the refractive index of the cornea is increased, and in nucleosclerosis, in which the refractive index of the lens is increased because of increased density. Hypermetropia is the opposite of myopia, which is also called farsightedness or long-sightedness. In the hypermetropic eye, the second principal focus lies behind the retina, as it is seen in the diagram. Types of hypermetropia are axial, in which the eye is short relative to the focal power, and in refractive hypermetropia, the refractive power of the eye is inadequate to focus the rays on the retina. For example, in aphakia. Other types are manifest, in which is actually the strongest convex lens correction that can be given to the patient. Latent hypermetropia, that is corrected naturally by the ciliary tone and involuntary accommodation of the eye. Facultative hypermetropia, that can be overcome by accommodation, and absolute hypermetropia, that cannot be overcome by accommodation. The third type of refractive error is astigmatism, in which there are different meridians and image is not formed at a single point on the retina. There are two focal points that, as can be seen in the diagram. This is focal point number 1 and the other is 2. And the interval between them is known as the stern sphenoid or the interval of stern. There are several different types of astigmatism, like regular astigmatism, in which the meridians are at 90 degrees to each other. Irregular astigmatism, in which the meridians are not at 90 degrees to each other. Then there is simple astigmatism, compound with the rule, against the rule, and oblique astigmatism, in which the meridians are at 90 degrees to each other but they are neither horizontal nor vertical, like 10 and 100 degrees. Simple myopic astigmatism is when one meridian is focused on the retina and the other is focused in front of the retina. Simple hypermetropic, one on retina and one behind retina. Compound myopic, both in front of the retina. Compound hypermetropic, both behind the retina, and mixed, one in front and one behind. In with the rule astigmatism, the vertical meridian is more curved as compared to the horizontal meridian. So for its correction, concave lens can be prescribed in the horizontal meridian, or convex lens can be prescribed in the vertical meridian. And in against the astigmatism, horizontal meridian is more curved as compared to the vertical meridian, so concave lens is prescribed in the vertical meridian or convex in the horizontal meridian. And isometropia is the optical condition in which the refractive power of the two eyes is not equal. Small degree of anisometropia is common and it is of no concern. But if there is larger degree of anisometropia, this can lead to myopia. And if there is a difference of more than 4 diopters, that can lead to diplopia. What is myopia? It can be unilateral or bilateral decrease of visual acuity that is either caused by pattern visual deprivation or abnormal binocular interaction, for which no obvious causes can be identified in physical examination of the eye. And it cannot be corrected by optical or surgical means, but it can be corrected by therapeutic measures. For example, if there is a difference of more than 2 lines between 2 eyes on the Snellen's chart, like one eye is 6/9 and the other is 6/36, this can lead to myopia. Visual acuity of the myopic eye is mostly less than 6/9. Diplopia is commonly called double vision, and it is actually the subjective complaint of seeing more than one image, that is 2 images of an object instead of one, as can be seen in the diagram. Types of anisometropia. Simple anisometropia, in which one eye has no refractive error and the other eye is either hypermetropic or myopic. Compound anisometropia. Both eyes are either myopic or hypermetropic, but one eye has more refractive error as compared to the other. Mixed anisometropia, in which one eye is hypermetropic, other is myopic. In comparison of hypermetropic eye and myopic eye, a disparity of more than 1 diopter in the hypermetropic patient is enough to cause myopia, because accommodation is because of binocular vision. And myopic patient is less likely to develop myopia because accommodation is because near vision is better as compared to distance vision. Older patients with nuclear sclerosis leading to index myopia, more than one eye cannot tolerate full spectacle correction as compared to young myopes who have cataracts in older age, because older patients are not accustomed to that myopia. Pinhole test is a method that is used to determine whether reduced visual acuity is because of refractive error or because of ocular pathology or neurological disease. If it's because of refractive error, then pinhole acuity will be definitely better than unaided acuity. If because of ocular pathology, then no improvement is seen with pinhole, and in macular disease, the pinhole acuity is actually worse than the unaided acuity. The principle of pinhole is that only a single ray of light comes from the object from a single point, and it passes through the screen. That is why a very clear image is formed regardless of the position of the screen, and the screen is actually the retina in the human eyeball. If we consider errors that are outside the range of +4 diopter and -4 diopter, they cannot be corrected with pinhole to 6/6. So it is more applicable to low degrees of refractive error. For example, we have low myopia of 6/18 vision without a pinhole. It can be corrected to 6/6. But if it's counting fingers, it will not be corrected to 6/6. It will only be corrected to 6/12. And in low hypermetropia, 6/18 will be corrected to 6/6, but not 6/60 to 6/6. The principle of pinhole is applied in stenopic slit, in which only light in one axis is allowed to enter the eye. For example, this slit shows vertical axis. So light in the vertical medium will only be allowed to enter the eye. Then the slit is rotated in the position where the clearest vision is obtained, either vertical or horizontal. Spherical lenses are added in that axis for further improvement. Then the slit is again rotated to the opposite axis. For example, if it's 90, then it will be rotated to 180. And then spherical power is adjusted accordingly. Cylindrical correction is always the algebraic difference between the two spherical directions. And the original direction of the slit, that, for example, in this case it was 90, that will be taken as the axis. Another point is that we use stenopic slit for determining the axis of the cornea with least deformity. And that axis is used in case of optical iridectomy procedure. What is the far point? Position of an object such that the image falls on the retina with accommodation at rest in the relaxed eye. In case of Ametropia, it is present at infinity. In case of myopia, it is present at a finite distance but in front of the eye, so it is given a sign of negative. And in case of hyperopia, it is present at a virtual point behind the eye, so it is given a plus sign. Why do we correct Ametropia? The purpose is to deviate the parallel incident light so that it appears to come from a far point in myopia and to be converging on the virtual far point in case of hypermetropia. The far point must coincide with the focal point of the lens, where focal length is considered the distance between the far point and the principal plane. In this diagram, you can see the distance between the far point and the principal plane is the focal length, and if it's equal to the distance of far point from principal plane, then f is equal to 1 over f or 1 over r, which is the power of the lens that will be prescribed to the patient. The reciprocal of far point distance, where r is in meters, is equal to 1 over r, and it is symbolized by r. It is expressed in diopters, and it is known as the static refraction or ametropic error. For correction of myopia, concave lens is placed in front of the principal plane, where focal length should be equal to the distance r, and far point should coincide with the focal point, which can be seen. And in correction of hypermetropia, convex lens is placed in front of the eye, and the focal point should be coinciding with the far point. Summary is that myopia is corrected with concave lenses, hypermetropia is corrected with convex lenses, astigmatism is corrected with cylindrical lenses, and pinhole is used to identify cause of decreased visual acuity. Synopic slit works on the principle of pinhole.
ब्लड है, अब उसको ब्रेन पे जाके परसीव होगा, ब्रेन लेवल पर क्या होगा?
सर मेमोरी नहीं बनेगी उस विजन की, उस साइड, उस लोब ऑफ द ब्रेन।
ब्रेन ऑफ करता है बेस्ट इमेज को, वो बाद में भी यही करता है और चाइल्डहुड में भी यही करता है, बेस्ट इमेज को ऑफ करेगा। जब बेस्ट इमेज को ऑफ करेगा तो ब्लड इमेज को क्या कर देगा? सप्रेशन, उस फिनोमेनन को सप्रेशन कहते हैं। यही वजह है कि एम्ब्लायोपिक आई स्क्विंट नहीं करती। अगर स्क्विंट की वजह से एम्ब्लायोपिया अलग चीज़ है, लेकिन रिफ्रैक्टिव एरर के अंदर एम्ब्लायोपिया अगर है तो एम्ब्लायोपिक आई कभी स्क्विंट नहीं करती, इसलिए कि वहाँ सिर्फ सप्रेशन हो रही है। लेकिन जो पॉइंट टू पॉइंट एडजस्टमेंट हुई है आपस में, वो चेंज नहीं होती, खासतौर पर पेरिफेरल में। पेरिफेरल जो उसके पॉइंट्स हैं वो एक करस्पॉन्डिंग पॉइंट्स एक दूसरे के साथ अटैच हैं, वो रहते हैं, जिसकी वजह से आई स्क्विंट नहीं करती। तो सेंट्रल पॉइंट सप्रेस कर गया। अब सेंट्रल पॉइंट सप्रेस कर गया तो क्या हो गया? एम्ब्लायोपिया हो गया, उसकी विजन कम हो गई। तो इसका करेंगे क्या?
सर पैचिंग करते हैं गुड आई की, ताकि विजन डेवलप हो जाए इन द वीक आई।
पैचिंग क्यों करते हैं? ताकि उस ब्रेन को मिले सिर्फ वही इमेज, जब वही इमेज मिलेगा तो आहिस्ता आहिस्ता उसकी विजन बेहतर हो जाएगी। तो इसमें मायोपिया क्यों नहीं करता एम्ब्लायोपिया, और हाइपरमेट्रोपिया ज़्यादा क्यों करता है?
मायोपिया
में नियर विजन हमेशा ठीक रहती है। इवन वेरी हाई मायोपिक पेशेंट्स, उनका जो एम्ब्लायोपिया का बेहतर रिस्पॉन्स है, एम्ब्लायोपिया नहीं होता उनको, क्योंकि नियर विजन की फिर भी मिल रही होती है, ब्रेन को कहीं ना कहीं से कोई बेहतर इमेज मिल रहा होता है। और एम्ब्लायोपिया की जब आप ट्रीटमेंट करने जाते हैं तो सबसे पहले नियर विजन बेहतर होती है। अगर बहुत डेंस एम्ब्लायोपिया भी है, आफ्टर 6 मंथ्स आप देखेंगे पेशेंट नियर से पढ़ना शुरू हो जाता है, डिस्टेंस विजन भी वैसी ही होती है, फिर आहिस्ता आहिस्ता वो डिस्टेंस विजन भी बेहतर होना शुरू होता है। तो दैट्स द रीज़न कि ये मायोपिया में चूँकि किसी न किसी पॉइंट पे कोई ना कोई पॉइंट ऐसा जरूर है जहाँ उसकी बेहतर विजन है, उस पॉइंट का जो इमेज है वो ब्रेन परसीव कर रहा होता है, जैसा एम्ब्लायोपिया डेवलप नहीं करता। वैसे ये आज का लेक्चर सर मुझे समझ नहीं, सिर्फ ग्लॉसरी का लेक्चर था।
इसमें बेसिक कॉन्सेप्ट जो है ना, वो ये मिसाल के तौर पे एक सिलेंड्रिकल लेंस है, तो इसका जो ये मेरिडियन है, सरफेस है, ये कर्व है, सो इसको हम कहेंगे वर्टिकल मेरिडियन कर्व है। मेरिडियन को कैसे डोनेट करते, कैसे आप लिखते हैं मेरिडियन? मेरिडियन को लिखते हैं एट द रेट ऑफ, जिस तरह gmail.com होता है ना, एट द रेट, उसको पढ़ते भी हैं एट। सो इस कंडीशन में जबकि वर्टिकल मेरिडियन ज़्यादा कर्व है, इसको हम लिखेंगे सिलेंडर है एट द रेट 90, और इसको आमतौर पे विद द रूल एस्टिग्मेटिज्म कहते हैं, क्योंकि यंग बंदों में जो अपर लिड है, अपर लिड presses on the cornea and produces more curve in the vertical lid. Now the horizontal line, this cylinder does not have any power in the horizontal axis. This is called axis, and this is written as cross. So I will write this cylinder has 4 diopter cross 180 degree. It is not read as 0 degree, though it is same 180 or 0, but we write 180 degree. So to counter this cylinder with the rule astigmatism, we will have to incorporate a cylinder in front of the eye with meridian in the which direction? Horizontal direction, and axis in vertical direction. So this combined will make a sphere, and you can negate the sphere with appropriate minus lens. Or the other way to counter this astigmatism is to give a concave cylinder with axis in the same direction but having opposite power. Minus, let's say 4, with axis in which direction? 180. So you can negate this cylinder with a negative concave lens with the same axis, or you can add a plus lens to make it spherical, and you can then negate the spherical part.
-4 में 180 +4 होगा।
देखना ये है, for example +4. Now this is in the vertical meridian. Now you add another cylinder with +4 at right angle. So this will make it +4 spherical. You will have to add -4 spherical lens also to make it 0. Right? So if you want to add a concave cylinder, then you can add it with axis at 180.
Opposite power.
Opposite power. So how do you write the VN? Yes. There are different